Okay, here we go. Deep breath. We've got the recording going, and we're going to be going over the practice test that is uploaded to D2L. Are y'all ready?
Yes.
Okay, starting with number 2. I warned you I may jump around, okay? Number 2, it says convert the angle in radians 2 degrees. Round to the nearest hundredth if necessary. So does anybody know what I multiply by to go from radians to degrees? 180 over pi. To go from radians to degrees, you multiply by 180 over pi. Now this negative 3 pi is understood to be over 1. And can you see what's going to happen to my pi's? So just like on Thanksgiving Day, the pi's go away. And then we're going to multiply straight across. What is negative 3 times 180? And that'll be over 1. And so negative 540 over 1 is negative 540. Do y'all see how that works? Yes.
Will you take out points if you don't put the degree symbol?
If it says convert the angle in radians 2 degrees, if the answer is a degree and you don't put the degree symbol, I may count off for that.
Like half a point or like this one?
Like a point. Yeah, not severe, okay? But y'all do understand that's when I taught this class, that was the major designation I said that determined a radian from a degree. It's whether you have the circle or not. So if you don't put the little circle, you could say, hey, that's a radian. Okay. Any questions on number 2? Okay, number 4. Okay, it says a point on the terminal side of an angle is given. Find the exact value of each of the 6 trigonometric functions. We're going to have to find all 6 trig fractions, and the only thing we have is a point. So what can I do with a point? I can plot it. Okay, so let's put the dot in the right spot. 1, 2, 3, 4. 1, 2, 3. Looks like that's in quadrant 4. Now, from that point, let's construct a right triangle. So we're going to drop straight down from the x-axis, and then we're going to connect the dots with the origin. And does everybody remember that theta is the angle at the origin? Theta is going to be at the origin. What is the length of the horizontal side? What is the length of the vertical side? Do I know the hypotenuse? It's not given. Can I find it? Pythagorean theorem, okay? 4 squared plus negative 3 squared equals h squared. 16 plus 9 is 25. And then taking the square root, we can see that h is 5. And the last thing that I need to do before I can actually come up with the answers, I need to determine, is negative 3 the opposite or the adjacent? Well, here's theta. So negative 3 is the opposite. And that means that 4 has to be the adjacent. And now we can talk to the chief. Soka Toa. Sine theta is O over H. Cosine theta is A over H. Tangent theta is O over A. Everybody see how that works? So you're going to have to construct the right triangle by plotting the point. You're probably going to have to use Pythagorean theorem to get the hypotenuse. You definitely have to label your sides correctly, O, A, and H, because that'll screw it up badly if you don't label those correctly. And then you just talk to the chief. So far, so good? Now, did y'all notice that the instruction said find the exact value of the 6 trig functions? So I'm also going to need cosecant, secant, and cotangent. But if you can get the first 3 right, those should be gravy. And that means easy. Negative 5/3, 5/4, negative 4/3. Question. When you do the reciprocal of a fraction, the sign is not affected. If you flip a fraction over, it won't change its sign. Any other question? Oh, I'm sorry, I said any. Any other questions? Are you ready to move on? Okay, here we go. Next problem. Number 6. Okay, so for problem number 6, it says determine the amplitude, the period, and the phase shift. Then graph at least one period of the function. We're also going to have to use the graph to determine the domain and range. So we got a little bit to do here. Let's get started. Part A. What is the amplitude of this wave? What is the amplitude? 5. Remember, the amplitude is always positive. Remember, the formula says absolute value of the lead coefficient. What about the period? That's going to be 2 pi over b, which is 2 pi over 4, which reduces to pi over 2. That's the period, 2 pi over b. And if you need to label these at the top, it's okay. A, B, and C. You can label those if you want. Everybody see what I'm talking about? And last but not least, we need the phase shift. Okay, that is negative C over B. If you forgot the formula, negative C over B. So that's going to be pi over 2 over 4. And I think that reduces to pi over 8. Any questions so far? Come on now. If you have a question, you need to ask. Okay. Now, to the graph. Remember my 6-step method of graphing. There are 6 steps to doing a sine or a cosine wave. Step number 1, starting point. Do I have sine or cosine? And remember, sine starts at the origin. Step number 2, phase shift. I do have a phase shift. It is positive. So this point at the origin is going to shift to the right. How far? A pi over 8. And so now I'm going to make that dot a little bit more solid because that is the actual starting point. Sine starts at the origin, but the phase shift moves it over, okay? Step number 3, wavelength. What is the period? Pi over 2, okay? And in order to travel that distance, I'm going to do it in eighths. So how many eighths make a half? 4 eighths. Here we go. 1, 2, 3, 4. Right? Do each one of these look like an eighth? 8 and an 8 and an 8. Y'all see that? I made them all the same. Okay, so is this where I'm starting? Okay, now watch this. 1 8, 2 eighths, 3 eighths, 4 eighths. But 4 eighths reduces to a half. And so now this is the distance that I'm going to travel. If I start on the x-axis, I'm going to finish on the x-axis. That's going to make one complete wave, okay? Now, what is this endpoint going to be labeled? What? 5 pi over 8. And does everybody see why it's labeled 5 pi over 8? Because from the origin, I went 1, 2, 3, 4, 5, and those are all eighths. 5 pi over 8. Now, what step am I on? Step number 4? 4 spaces. Oh, and look at that. 1, 2, 3, 4. I got my 4 spaces, okay? So that's done. Step number 5, lay out your points. I'm starting on the x-axis. Is this graph going to go up first or down first? Down, because the original 5 is negative. So we're going to go 1, 2, 3, 4, 5. And at the first hash mark, I'm going to be at negative 5. What about the next hash mark? It's going to be back to the x-axis. Next hash mark. We're going to be up to positive 5. And we're going to finish on the x-axis. Now, can y'all see that those points, the way they're laid out, it makes a nice smooth curve. And so step number 6 is connect the dots. We've got a valley right there, and we've got a hill. Like that. Yeah.
Step number 4.
Yeah. Step number 4 says you got to have 4 spaces. From start to finish, you have to have 4 spaces. Now, do y'all know why it's 4 and not some other number? Because if it's 4 exactly, those hash marks are your critical points. If you have any other spacing, you can't guarantee where those points are going to be.
So there's always 4 spaces.
Always 4 from start to finish, okay? Yes.
And what chapter is this? If they want to review it with the
What chapter was that? I'll have to look that up. I don't have that in front of me.
chapter 6 of 8.
Okay, thank you. Teamwork, I love it. Okay, last thing we need to do. Now that we've got the graph, and did y'all notice that is at least one period? That's one wavelength. I also need the domain and the range. So what is the domain of every sinusoidal function? Right? Because it's going to snake forever along the x-axis. It's going to wave along the x-axis in both directions infinitely far. But what about the, go ahead.
Well, you said that's for every sinusoidal?
Every sinusoidal.
So that's like for...
Sine and cosine. Sinusoidal means sine and cosine. Okay? Now, what about the range? Bracket -5? +5 bracket? Because this wave is never going to get lower than -5 and it'll never go above +5. And are there any other questions about problem number 6? Yeah.
I actually had a question about sine wave. Is it possible for the sine wave to get bigger? Like as it goes?
I don't think it would be considered sinusoidal if the amplitude changes. But I do know it is possible to create a wave that does that. That's possible. Yeah.
So would we only need to do 2 periods if the question asked for us to do 2 periods?
If it specifically said graph 2 periods, then you only need 2 periods. And this one said at least 1 period. So if you wanted to do more, you could. But I need at least 1. Got it? And I'm sorry, back to your question, Matthew. I know for sure that it exists because in physics, if you want to model a sound wave, sound waves tend to decrease over distance. Like the amplitude will decrease, and so that can be modeled mathematically, yeah. All right, are y'all ready for the next problem? Okay, next. Number 7. And the instructions say graph at least 2 periods, of the function showing any asymptotes as dotted lines. Now this is a tangent function, and instead of the 6 steps that we have for sine and cosine, this is going to be a 4-step. All right, so let's start. Step number 1. Remember that tangent is bounded between -π/2 and π/2. And when I say bounded, I mean that's going to be 2 consecutive asymptotes from -π/2 to π/2. Does anybody remember the bounds for cotangent? 0 to pi. Tangent is -π/2 to π/2. Cotangent 0 to pi, okay? And then what I'm going to have to do, after I put the angle in the middle, I'm going to have to solve that for x. So what do I need to multiply by to get x by itself? 4. We're going to multiply everybody by 4. So that's going to be -2 pi. And that's going to be +2 pi. Now, the reason that we did that process right there is to establish 2 consecutive asymptotes. So at -2 pi, I'm going to have an asymptote. And at +2 pi, I'm going to have another asymptote. And do you know what I mean by consecutive? One after the other. There won't be another asymptote in between those. Those are 2 consecutive asymptotes, okay? Step number 1. Okay, step number 2. X-intercept in the middle. In the middle of those two asymptotes, we're going to have an x-intercept. Step number 3. At the first and third quarters, we're going to have a y value of negative a and a respectively. At the first and third quarters, we're going to have a y value of negative a and a respectively. Now remember, these flip-flop for cotangent. For cotangent, it's a and then negative a. Okay? Oh, and did y'all see my a is negative? So that'll make it a positive. Okay? Right here. So really, instead of being at negative 2 first, I'm going to be at positive 2 first. And it'll also flip the positive to a negative. You don't get that? Okay. So when I say the first and third quarters, if you look from one asymptote to the other, quarters means 4, right? 4 quarters is $1. So here's the first quarter, second quarter, third quarter, fourth quarter. Okay? So at the first quarter, I'm going to be at negative a, which would be down here, but the a is negative. So minus a negative actually makes it a plus 2. And then at the third quarter, I would be at positive a, but a is negative. So then at the third quarter, I'm going to be at negative a. And then step number 4, connect the dots. Now, how many wavelengths is that? How many periods? That's only one period. So I'm going to have to go 1, 2, 3, 4. And I'm going to have to go another period. All right, so here we go. In the middle, x-intercept. We're going to be at positive 2 and negative 2. And if I just copy and paste, bam, I get another wave. Where would that third asymptote be? Not 4 pi, 6 pi. Y'all see why? Because every 2 spaces is a 2 pi. So that means every 1 space is a pi. 1, 2, there's 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. How's that? You like it? You don't have to like it. You just have to know how to do it. And that's it for number 7. Cotangent is 0 to pi.
That's flipped, right? It's flipped, right? You start at positive and negative.
Right. Right. If this would have been cotangent, then this would be positive and then negative. Yeah.
So it's going to start in the origin?
If it's tangent, yes. And now if it's cotangent, no. Because cotangent, the asymptotes are 0 and pi. And so it'll actually start in between them. Okay, unless there's a phase shift, and then it shifts it, okay? Man, y'all might want to go back and review some of that stuff. Yeah, that might be a good idea. All right, who's ready for the next problem? Are you ready? Okay, here we go. Next, Number 11. Find the exact value of the expression. Show your work. So even though the calculator may do it for you, you're going to have to show how you get the answer. And lucky for you, I am going to show that, okay? Does anybody remember what an inverse trig function equals? An angle. An inverse trig function is always an angle. And so we're going to say theta equals the inverse sine of negative square root of 3 over 2. And then we're going to take the inverse sine, we're going to move it back over. And we're going to have sine theta equals negative square root of 3 over 2. Now, do y'all remember in the unit circle, sine is y? So what we need to do is we need to go to the unit circle and we need to find an angle that has a y value of negative square root of 3 over 2. And that has to be quadrant 4. Because inverse sine, remember, is restricted to the first and fourth quadrant. So those of you that have your unit circle handy, and just for fun, I'm sorry, it's not 11 pi over 6? I so much wanted you to be right. I just wrote it down. Why can't it be in quadrant 3? Because we're doing inverse sine. Inverse sine, remember, is restricted from negative pi over 2 to pi over 2, which is quadrant 1 and 4. Now, what trig function allows me to go to quadrant 3? Inverse cosine. Because inverse cosine is bounded from 0 to pi. And then inverse tangent, remember, is back to negative pi over 2 to pi over 2.
So you said inverse sine is the first and the fourth?
First and the fourth. Inverse cosine is first and second. I'm sorry, did I say quadrant 3? I just now realized what I said. Inverse cosine is restricted from 0 to pi, which is quadrant 1 and 2. So you're never looking at quadrant 3. When you're doing an inverse trig function, you're never going to pick an angle from quadrant 3. And then inverse tangent is back to quadrant 1 and 4. Okay, I'm just trying to cover all the bases there. All right, so what is the actual angle that has a y coordinate of negative square root of 3 over 2? What is it? 5 pi over 3. Oh, I know what I wanted. Can you tell me the x coordinate at that location? What is the x coordinate at that angle? Is it half? Yeah? Just because I felt like it. Okay. Oh, and because I kind of know where I'm going. Okay. So if you look back over here at the problem, what I'm really interested in, I'm interested in secant of theta. But isn't secant of theta 1 over cosine theta? But isn't cosine in the unit circle x? And what is the x coordinate? A half. So that means that my answer for secant theta is going to be 1 over a half, which is 2. So the answer, I'm sorry, let me double box that. So the final answer is 2. The actual answer is 2. And now you can use your calculator if you want to check your handwritten work. Anybody type this into your calculator? Oh, wait a second. You're going, how the freak do I put sec into my calculator? Remember, you have to do 1 divided by cosine to do that. So we would do 1 divided by cosine, parenthesis, inverse sine of that.
What if it was secant inverse? Like how would you put that in the calculator?
Like this is an inverse 2? Yeah, you're not going to see that.
Okay.
Yeah. You won't see a double inverse there.
Yeah, but like I'm just saying, what if like it was another question and secant had an inverse?
Oh, and secant had an inverse.
Instead of sine.
So what you do, this would be inverse secant, okay?
Mm-hmm.
You'd bring it over, this would be secant, right?
Oh, got it.
And then you would flip to turn it into a cosine. Because the reciprocal of secant is cosine. So you'd have to flip both sides there.
So there's no way to put secant inverse in the calculator?
Nope. You have to do either sine, cosine, or tangent.
Got it.
Did anybody input that the way I said, and did it spit out a 2? Well, good. That's always nice. Let's see, how are we doing on space here? Space. Okay, I got some space here. Let's go to number 12 next. Jump around. And for number 12, you're going to have to know how to solve a trig equation. And this one specifies that you want to solve on the interval from 0 to 2 pi. So we're going to find all the angles in the unit circle in 1 revolution of the unit circle that solve this equation. And the first thing I need to do is I need to isolate the trig function. So who needs to move over? So we're moving the 1. A half minus 1. Negative half. And then I've got negatives on both sides. I'd like to get rid of those. So if I divide both sides by negative 1, that'll make both sides positive. Got it? Now, in the unit circle, sine is y. So I need you to find all of the angles in the unit circle that have 1/2, positive half, as a y coordinate. All of the angles in the unit circle that have positive half for a y coordinate. And as soon as you've got those, I'm ready. Everybody agree with that? Do you think it's going to be necessary for you to have the unit circle in front of you? Yeah. Oh, did I say you can't use a formula sheet? Or did I say you can? Did I say whether you could or not? Okay. But just one, right? Okay. All right, what's next? That's number 12. Next problem, number 14. And it says, use a sum or difference formula to find the exact value. Use a sum or difference formula to find the exact value. And I'm thinking, let's try using a difference formula. It's probably going to be easier to come up with two numbers that subtract and make pi over 12 than add. All right, so let's think of some angles that subtract and make pi over 12. How about 2 pi over 12 minus 1 pi over 12? Does that subtract and make pi over 12? And are both of those angles in the unit circle? Now the first one is, that's pi over 6, but pi over 12 is not in the unit circle. So this is not the pair that I want, and so we're going to increase. How about 3 pi over 12 minus 2 pi over 12? Does that subtract and make 1 pi over 12? And what does 3/12 reduce to? And what does 2/12 reduce to? Now can you see I have found a pair of angles that subtract and make pi over 12, and they're both in the unit circle. Now you're going to have to look up the formula for tangent of alpha minus beta. You're going to have that formula, tangent alpha minus beta. And as soon as somebody's got that, I'd like to know it. Tangent alpha minus tangent beta. And that's just something you're going to have to memorize, right? All right, so let's plug and play. We're going to have tangent of, what was alpha? Pi over 4 minus tangent, what was beta? Pi over 6 all over 1 plus tangent pi over 4 times tangent pi over 6. And now you're going to have to calculate those values. Tangent of pi over 4, I think that's 1. Tangent of 45 is 1. How about tangent of pi over 6? Anybody know what the value of tangent of pi over 6 is? I'm ready. Not everybody at once. Square root of 3 over 3? All over 1 plus 1 times square root of 3 over 3. Everybody see how we get square root of 3 over 3 for tangent of pi over 6? Well, there's two ways you can do it. You can do it with the calculator, or you can go to your unit circle at pi over 6, and you can do the y coordinate divided by the x coordinate. Remember, tangent is y over x. And if you divide that, you get your square root of 3 over 3. Now we're going to have to simplify that. That is too effed up. We're going to have to simplify it. So I'm going to multiply the numerator by 3. And whatever I do to the top, have to do to the bottom. And that 3 is going to distribute. 3 minus square root of 3. 3 plus square root of 3. And even though that has a square root in the bottom, I think I'm pretty happy with that. Yes, sir.
Whenever we're rationalizing fractions that have a square root at the bottom, when is it that we need to multiply by the conjugate or the other option?
Okay, good question. When the denominator is a binomial, that's when you have to use the conjugate, which would be 3 minus square root of 3. And so you'll have to multiply top and bottom basically by this, okay?
But if it's just one term, the top and bottom, then you...
If it was just square root of 3, a monomial,
Right.
then you just multiply top and bottom by the square root.
Wait, so even we can do the answer like this?
It's okay with me. Now, if you want to fix it, if you want to rationalize that, you can. Your calculator does it quite nicely. I think some of you may be able to input this and it goes straight to the answer. I don't know. Does it really?
That's what I got, so I thought it was wrong.
What did you get?
Negative square root of 3 plus 2. But
Like
then I
what?
typed that in, it gave me that too.
You type this in
That in, and that.
and this,
Same thing.
and what did they both give?
Negative square root of 3 plus 2. So we can have just
You got 2 minus square root of 3?
Yes.
That's fine too.
Did you have just to work it out?
Huh?
Did you have just to work it out?
There is a chance that it will say must show work on the test. There is a chance. And so that's where you're going to have, do you see how I demonstrated the work I want to see? Yeah, Chris.
So when you're 2 pi over 12 further up, so you just, if you weren't able to find it, you would just keep going, so 3 pi minus.
Yeah, so 3 minus 2 is 1.
And then
4 minus 3 is 1. 5 minus 4 is 1. And you're going to keep going until you find 2 that reduce to make unit circle angles. And it is possible, okay? So don't put no solution because there is going to be a solution. Any other questions before I move on to the next one? Okay, number 16. Jump, 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 jump around. And this problem says, use the information given along with a double angle formula to find the exact value of the indicated trig function. They want us to find cosine of 2 theta. That's what they want us to find, cosine of 2 theta. Now, if memory serves me, I think in your formula sheets, there's actually 3 formulas for cosine of 2 theta. You've actually got 3 choices. And the one that you pick should be based on what they gave you. So do y'all see they gave me cosecant? What trig function is related to cosecant? Sine, okay? So watch this. If I take this information, I can say sine theta is negative 3 over 4. Right? Because cosecant is the reciprocal of sine. So if I flip this side, I've got to flip this side. And then can y'all tell me what is the double angle formula I need to use? Anybody?
Cosine of 2 theta equals 1 minus 2 sine squared.
Yeah, so I want to use the formula that says 1 minus 2 sine squared theta because I think that's the only one that involves only sine. And so now we can take this information and plug it in here. And with a little luck and a little button pushing, hopefully you can get that worked out. Okay, so that's going to be 9/16, which is 9/8. 1 minus 9/8. I'm thinking negative 1/8. Anybody have any questions about that problem? Go ahead. Oh, it says find cosine of 2 theta. So if it says to find cosine of 2 theta, that indicates a double angle formula right there. That guy right. What if it said to find sine of 2 theta? Tangent of 2 theta. Those are all double angle formulas. Yeah. Yeah.
So if the tangent greater than 0, that's just making sure it's positive?
That's making sure that you know what quadrant you're in. Yeah. So if sine is negative and tangent is positive, then that means we're in the third quadrant, and cosine should also be negative. Okay? So I'm just making sure you get the sign right. Are y'all ready for the next one? Okay, here we go. Let's see, how far down am I? I think I'm going to fit one more in here, number 17. Sine of 22.5 degrees. And the instructions say, use a half angle formula to find the exact value. Use a half angle formula. And so what that means, it means I'm going to have to come up with an angle that when I take half of it, I get 22.5. Everybody agree with that? 45 divided by 2 is 22.5. And then this corresponds to sine of alpha over 2. So you're going to have that half angle formula available. What is the formula for sine of alpha over 2?
Square root 1 minus cosine theta over 2.
Did I get that right? And does it have a plus or minus out front? Oh, but how do we know whether it's plus or minus? Yeah, the quadrant. What quadrant is 22.5 in? First quadrant. Everything in the first quadrant is positive. So we know that's positive. And we're going to have to find the cosine of theta. Well, in this case, theta is 45. Does anybody happen to know the cosine of 45 degrees? And then we're going to have the square root of 1 minus square root 2 over 2 all over 2. And we're going to have to simplify that bad boy. All right, let's see if we can do that. Divided by 2, divided by 2. That's going to be square root of 1/2 minus square root of 2 over 4. Y'all see what I did there? I did the over 2 for both of these. 1 over 2 and this over 2. Gives me 1/2, and then 2 and 2 make 4. And then that's going to be, well, let's see, let's get a common denominator. Times by 2 times by 2. That's going to be the square root of 2 minus the square root of 2 all over the square root of 4, which is 2. There we go. Now, I don't think, even if you have the Casio, I don't think you can type in sine of 22.5 and have it spit that out. I don't think it'll display that answer. Will it?
No, sure.
I don't think it displays that answer. Does it just give you a decimal?
Yes.
Okay. But once you get your answer, can you type this into the calculator and see if it gives the same decimal number? And if it does, that verifies that you're right. So the calculator, even though it won't spit out what you need, it may verify that you're correct. Can I move on? All right, here we go. Next. Do what? I'm sorry. How's that, Avery? Oh, I keep adding pages. What am I doing? Clicking the wrong thing. What problem did I just do? I just did 17? 17. Next, let's go to number 20. And guess what it says to do? Yeah, prove it. It says establish the identity. These are your favorites, I think, where you have to use trig substitutions with algebra and work one side down to where it equals the other. Yeah, I like these. Are you ready? Okay, here we go. What did I say that a neat trick is to use? Yeah, so we're going to start by changing everything into sines and cosines. Do y'all know what tangent can be replaced with? What about secant? Cosecant is 1 over sine. And sine, well, sine is already sine. So I'm just going to go ahead and make it a fraction because I feel like it. And now you've got a choice to make. Do you want to distribute or do you want to combine in the parentheses? You want to combine? Okay. I'm going to need a common denominator. So what's going to be the common denominator for these two? Sine u. So I'm going to multiply this by sine u. If I do it to the bottom, and that's going to make him a squared Sine u times sine u makes him sine squared u. And then we're going to have sine u over cosine u times 1 minus sine squared u all over the common denominator. And then what do you notice is going to happen with my sine u's? Sine u on top and bottom, those cancel. Oh, and does anybody know a substitution for 1 minus sine squared? Cosine squared. So 1 minus sine squared u can be replaced with cosine squared u. Remember, that's a Pythagorean relationship. And if I multiply straight across, that's going to put my cosine u in the bottom. And then which has more cosine u's, top or bottom? How many more does he have? So this guy is going to cancel out one of those. And we're done. $22. There we go. What kind of triangle is that? Right? And the instructions say solve. Solve the right triangle. That means we're going to have to find all of the missing pieces. So how many pieces do I not know a value for? 3. There's 3 pieces that are missing. I don't know angle A. I do know angle C though, right? 90. But I don't know little c. And I don't know little b. Oh, but we can find A. So what is angle A? 65? 55. What about little b or little c? Anybody have an idea how to get one of those? I'm ready. Wait, sine 90 over little c. Sine. That looks good to me. Anybody else agree with that? And if you want to use the law of sines instead of SOHCAHTOA, that's fine with me. So little c is going to be 4 sine 90 divided by sine 55. And I believe it does say round your answers to 2 decimal places. So I'm going to need that calculated to 2 decimal places. Anybody? $4.88. Anybody agree? 4.88. I'm seeing a lot of heads shaking yes, and one shaking no. Oh, you better make sure you're in the right mode. Make sure you're in degree mode. 4 sine 90 divided by sine 55. A squared plus B squared equals C squared. Can I use Pythagorean theorem? Because it is a right triangle. And so we can say 4 squared plus B squared equals 4.88 squared. And then I can solve for little b like this. 4.88 squared minus 4 squared. And then whatever that is, we're going to have to take the square root of it. Yes, sir.
2.79.
Is that the final answer?
Yeah, unless you round it, then it would be 2.80.
What's after the 9?
That's why I said if you round it, it would be 2. Oh, that's a 5.
After the 9 is a 5? Okay, so we do need to round it to 2 places. So that's going to be... Everybody agree that it's 2.80 rounded? Okay. And that's number 22. All the missing pieces found. Yeah. Yeah, just a second. Bam. All right, we got about 5 minutes remaining. It looks like I'm not going to be able to finish, but I can squeeze in one more at least. So we'll do the bad boy before we leave. Number 24 is the bad boy. And the instructions say solve the triangle. Solve the triangle. How many angles are given? Is that angle acute? And is the opposite side less than the other side? Oh, snap. It's the ambiguous case. Y'all remember that? Oh. All right, so let's set up the law of sines and see if we can find whether there's going to be 6 answers or not. So what is the first fraction going to be? Sine 41 over 3. Sine A over 4. Cross multiply and divide. 3 sine A, 4 sine 41. Divide both sides by 3. And we want to do the inverse sine of that. Inverse sine of whatever that is. Anybody get an answer? What is it? 61? 61. 61? And is that rounded to the nearest tenth? All right, so if that's angle A and I know angle B, can I get angle C? 61 plus 41 plus what makes 180? Agree? Now listen, that guarantees we're going to have at least one set of answers. Now we're going to check and see if we have another set of answers. So remember when I taught this, I said you take the first angle you found and subtract it from 180. What is 180 minus 61? And now remember that your second angle C has to complete the cycle again. Right? So angle A plus B plus C makes 180. 119 plus 41 plus what makes 180? Is that right? 119? 119 plus 41, and then minus that from 180, what do we get? 20. Oh, I didn't hear. 20. Y'all already said it, I just wasn't paying attention, I guess. Am I done? No. What else do I need to find? Little c1 and little c2. Let's see if we can do that. All right, so remember I said it's good to recycle. So the 41 and 3 we're going to recycle. We're going to use sine of 78 to get little c1. And then we're going to have to set it up again. And we're going to use sine of 20 to get little c2. 3 sine 78 divided by sine of 41. 3 sine of 20 divided by sine 41. Let's go to the nearest tenth. 4.5 for the first one. 1.6 for the next one.
Yes.
Really? I just guessed. Is it 1.6? Bam. All right, and that is his